Hello VR folks, I hope you're all doing well. Yeah, I told you I'd make you a video on making some scripts and doing some basic movement from scratch in Unity for the Quest. So here we go. So the first thing you'll need to do is you should have a scene that you've mocked up already with all the necessary settings to get stuff running on your Quest. Apologies if the audio isn't great. My headset that I usually use when I'm doing this, battery's dead on it. So we're doing this off the camera mic, which may or may not be good. I don't know. But anyway, let me shrink down my video because I am not as important as the other things you're going to be looking at. Got our Unity environment here. So we've got a basic, plain, vanilla Unity environment. If you went through the tutorial video that I gave you at the beginning of the semester, you should have this. Most of you turned in functional projects, so you should, because this is what you would have started from. So really basic. There's the main camera that we actually got disabled because we don't need it because we're using the OVR camera rig. A directional light just so we have some light in our scene, and then I added a game object called scene. Now this is what I typically do when I make an environment, is I create an empty game object and just name it scene, and then add all of my other objects underneath that. And that way, if I need to move the whole scene around, I can just select this guy and move everything all at once. Okay, so that's pretty straightforward. So what we've got our camera rig. If you open it up, you've got some things in here. You've got your OVR camera rig, you've got the tracking space, and then you've got all these eye and hand anchors. We don't have to pay too much attention to these. Well, we do and we don't. For the purposes for the things we're going to be doing today, you won't have to pay too much attention to them. So this is representative of your left eye's position in the virtual world. This one's representative of your right eye's position in the virtual world. And this center eye anchor is what we call the cyclopean eye, so the eye position between the two eyes. So if you average the position of this guy and this guy, you get a centroid in between. That's where that guy is located. This is going to be the one we're going to be looking at today. Well, one of the ones we're going to be looking at today. So what we're going to be implementing is moving the camera in the direction of gaze when you press a button on the controller. So, essentially the most primitive, like, virtual flying you can do. Okay. But to do that, we've got to make some stuff. It's just a habit I have for how I make a virtual environment. I like to have objects designated to do certain tasks. Let's create a game object, and we'll call it our movement controller. That's it. And it's just a game object that I'm going to attach scripts to that'll be handling movement. Okay. So what we can do now is we can click Add Component over here in the inspector, and we can do New Script. And we'll call this Movement Test, just something simple. And create and add. Now notice it added the script here, but it also popped up down here in our assets. So what we can do now is, let's open this up. Okay. Let's get these guys side by side so we can see them. Okay, there we go. Okay, so your vanilla empty C# script that Unity is going to make for you is going to look like this. The basic things you want to look at is your start function. If you want something to be initialized or set in some way when the script the very first time it executes, you're going to want to put it in the start function. This is your update function. This happens approximately once a frame. It's a little more complicated than that, but you can usually assume that this is happening about once per frame. That can be variable. So your frame rate can vary, the update rate can vary. If you have something that needs to happen on very specific time increments, there's another function called fixed update that you can replace this with. But we're not going to look at that right now. We're just going to look at using the vanilla update function. Okay. So let's see. So what we're going to need to do, if we want to move the camera in the direction of the person's gaze, what we do is we actually move the camera rig. And so this is what we're going to be translating, or translating, rotating, so if you move this guy around, you can see that the Z position here is changing, Y position, X position, whatever. So we want to do that programmatically. We want our Unity environment to move the camera rig when we press a button, and we want to move in the direction the head is looking. So how do we know which way the head's looking? Well, let me show you. Right now I've got this thing, yeah, you can probably hear my kid playing in the background, it's okay. Anyway, so I've got it hooked up through Link right now so that I can show you in real time how these numbers change. The same concepts apply whether you're using Link or you're running the APK on your headset directly. So let's just start playing it, and let's click on our center eye anchor. Okay, there we go. And notice when I move this guy around, those numbers change. And that's what we want to intercept. So those numbers changing tell us oh, see, there's my hand, hi. Hand tracking is cool. Anyway, those numbers, especially the rotation is what we want to look at, is going to tell you the direction the head is looking. Now all of these numbers are relative to where the camera rig is located. So if we move the camera rig around, it's not going to really change the numbers we're getting out of this. So these numbers are going to be reported relative to where the camera rig game object is located. If you don't follow what that means, don't worry about it. It's not going to be too terribly important for what we're going to be talking about. Okay, so how do we get access to those numbers inside of one of our scripts? Well, first, let's go back to our movement controller. We're going to want to have access to the game object that is the center eye anchor. And how we do that is we make a public game object, and we'll call it eye. And we'll save this, and we'll go back over here and click in Unity, and something's going to happen over here. Whoa! This little new little box that's labeled eye and says none for game object has popped up. So whenever you make a public something inside of one of your scripts, that's going to show up as a little box that you can drag and drop things into or type into or whatever. In the case of game objects, you drag game objects into this box. So now what we can do is we can click on the center eye anchor and drag it over here into the eye box. And now this lets us get access to all of the information that's stored inside that camera center eye anchor. Okay, so what we want to do to get the gaze direction, the direction the person's looking, is we want to look at the eye's transformation. And specifically, we want to look at the eye dot transform dot local rotation. Now the local rotation is a vector 3, so 3 floating point values. That's actually not true. It's not true. Technically, you're getting a, I think you're actually getting, a 4x4 out of this, or are you getting a quaternion? Let's find out. Unity game object local rotation. Okay, yeah, it's just saying that it's going to return the rotation transform relative to the parent. Well, that's not really telling me what I want to know. Ah, here it is. Unity stores this internally as a quaternion. A quaternion is a neat way to represent three-dimensional rotations that is actually a lot more robust than using like Euler angles or 4x4s. Anyway, if you don't know what that is, don't worry about it. It's just something we're going to be multiplying another value by here in a minute. Okay, so what this will do, this will give us the rotation value for the eye anchor. And the rotation is where that head is looking. So the direction the head is looking. Now, once we have that, we want to make a new vector. That's not just a rotation, but the translated position along a certain direction. So what we can do is we can multiply this by a new vector 3 and have this be 0.0 f, because it's C#. If you don't put an f, it's going to complain. 0.0 f, and for this value, it's going to be 1.0 f. Now the question is why? 0, 0, and 1. Why did we choose those numbers? Well, the reason for that is because the representation is x, y, and z. X being this axis, y being your vertical axis, and z being your depth axis. So, relative to your head, when you're looking around, what we're going to want to do is we're going to want to translate the head in depth. So our z-axis. We're not going to be translating it this way or up and down. We want to get the direction we're looking and then move some distance in that direction. We're using a unit vector right now. And that unit, they're unity units, but you can assume that they're meters. So what this would do, it would move you 1 meter in the direction your head is looking. Now that's good, that's great, except 1 meter every time you press your button is really, really fast. And we can show you that. But now this line of code right here will perform that computation, but one, we've got to store it. So let's store it in a new vector 3. We'll just call it new direction. Okay, cool. Okay, so now we've computed a unit vector pointing in the direction that the head is looking. Now we have to actually move the camera rig. And to do that, we have to access the camera rig's position, which is not as difficult as it might sound. What you need to do is we're going to do something very similar to what we did right here. We need access to the camera rig. So we need to make a public game object, and we'll call it cam rig. Okay. We can save that. Let's go over here, and if we wait, there it is, camera rig. And we can drag our camera rig into this box. And this will give us access to everything that's stored inside of, or properties of, the OVR camera rig. Now the way to move it is actually really easy. So let's get this right here. What we do is we do camrig.transform, and if you haven't noticed, pretty much anything dealing with the translations or rotations or scale of an object is stored in object.transforms. Or transform. There is a function built in here called translate, though. And so you don't have to do any fancy linear algebra or anything like that. What we can do now is we can move the camera translate the camera rig in new direction. So super, super easy. We got the rotation of the eye, we multiplied it by the vector we want to move, and then we use that direction to translate our camera rig. Easy peasy, right? Okay, so let's save that, and let's run our environment. Ooh, something broke. Let's see what broke. Let's look at our errors here. Okay, game object does not contain. Oh, what broke is that I can't type. Okay, it says transform as opposed to transform. Okay, now we should work. Okay, so let's run our script and see what happens. Okay. Whoa, nothing's around here. Why? Oh, wait, what's that? Oh my goodness, something's flying at me really, really fast. And whoop, there goes our virtual world. So we have zero control pretty much of our speed here. So what we've got right now, we've got code that will keep you in continuous motion in the direction your head is pointing. But now notice you were moving really, really fast. That's because what's happening is you're effectively moving 1 meter every frame. So every time your headset updates the screen, you're moving 1 meter forward. That's really, really fast. What you really want to do is you want to make this smaller. So you want to multiply it by movement scale. So for every update, instead of moving 1 meter, let's say we want to move 10 centimeters instead. Now it's good to also make this a public, we'll go for a float, and call it movement scale. And that way we can edit our movement speed inside the inspector if we need to tweak stuff. Okay, so let's save this. Let's go back over here, and hey, there's our movement scale. Let's set that to 0.1, something not quite as crazy as 1 meter a second, or 1 meter per update. Okay, so now it shouldn't be quite so bad. Let's have a look. Okay, hey, that's much more manageable. We know we can see that we're flying towards it. We're going fairly slowly, so not bad at all. Woo! Kind of neat. Okay. But we want control over this, right? Right now, we're just always moving. We don't have any say-so in when we move. So what we want to do is let's get our controller, and let's say we try to bind our movement to a key press, like the A. So let's say every time we press the A, then we move forward. Well, there's a couple different ways to do this. The way using just the straight OVR input is probably the easiest way to get it going for our purposes. So what you can do is you can put all of this code here inside of an if statement, and so if the A button is pressed, then execute that code. So let's just do if OVR input dot get. Now the OVR input object lets you get access to all of these buttons and stick controllers and all this. So yeah, but you've got to tell it what input you want to get. There is a special language. By special language, let me show you the illustration. And I can post this on the Discord for the class if you want to see it. But every button on this is mapped to something like button.1, button.2, axis 1D, primary trigger, things like that. So you can enter these values inside of your OVR input.get function to get the values coming out of it. We're going to be using the A button, so we're going to be using button.1. So let's move that off the screen, and we'll do OVR input.button.1. And let's put this in some curly braces because this ain't no Python. This is a C language. Okay, so let's save that, and now let's run our virtual world. Okay. Okay. Oh, hey, there it is. Hey, guy. Whee! Whee! Okay. So let's get a little bit further away from it so we can see. So every time I press the A button, we move closer and closer. If I hold it down, we'll just zoom right through it. And there it is. Okay, so this is the most basic, most vanilla movement script you can possibly make for moving around inside of the Quest. Even though this is very bare bones, all of the other movement techniques that we talked about in class can be mostly implemented using what you learn from this super simple, effectively 3-ish lines of code. You know, this does something, this does something, and this does something. Everything else is just, you know, getting data from somewhere else. So you can get a lot of mileage out of just understanding what's happening in these 3 lines of code. And again, to just sort of go over and give you, reiterate, summarize, whatever you want to call it, of what's going on here, is this function gets called every time a frame updates. Sort of. A bit of an oversimplification, but effectively every time the frame updates, this function gets called. If you've pressed button 1, and according to our diagram here, button 1 is our A button. If button 1 is pressed, then we calculate a new directional vector based off of where the eye is looking. So the eye's local transformation. Its local transformation is its local rotation is its rotation relative to its parent object, which is the OVR camera rig. And we're going to multiply that rotation by the unit vector pointing forward in depth. And then we can translate the position of our camera rig using camerarig.transform.translate and the new direction multiplied by the scale of the movement you want to have. And that scale is going to be on a frame per frame basis. So in our example here, we had it moving 10 centimeters. So every time that screen flashed, you'd move 10 centimeters forward in the direction that you're looking. So yeah, it's a pretty simple script, but this should give you a good idea of, one, how to create scripts, how to attach them to objects, how to get public boxes for you to enter information into and access information from other game objects, and do some basic controller input. Oh, one more kind of cool thing. So with these kind of boxes, they're for game objects. You can drag the object in. But for things that are integer or float or double, if you put your pointer right on the edge, you get this neat little cursor. And look, you can drag it side to side as if it were a slider. And that gives you a way to do some rough adjustments. Okay. So I think that just about covers it. If you guys have any questions, please don't hesitate. Let me know. I'm happy to help you out. Yeah, I'm excited. This is actually one of my favorite. The navigation assignment is one of my favorite assignments that you guys do. So if you got questions about it, let me know. I'm just really, I want to help you make awesome stuff, because when I demo them, that's a lot of fun. And so I want to have fun using the environment that you built. Okay, so we'll go ahead and wrap it up there. And like I said, if you guys have any questions, just let me know. And I will see you in class.